During the following program, look for NOVA's web markers which lead you to more information at our website. Tonight on NOVA, it strikes with fury, with the energy of 500,000 hydrogen bombs, creating chaos across the globe.
None of the forecast models predicted how huge it would be.
Now, scientists confront the weather monster head on. Can they predict the next onslaught? How hard will it hit? Chasing El Nino. Major funding for NOVA is provided by the Park Foundation, dedicated to education and quality television.
This program is funded in part by Northwestern Mutual Life, which has been protecting families and businesses for generations. Have you heard from the quiet company? Northwestern Mutual Life.
And by iOmega, makers of personal storage solutions for your computer, so you can create more, share more, save more, and do more of whatever it is you do. iOmega, because it's your stuff.
And by the Corporation for Public Broadcasting and viewers like you.
We live in an ocean of air, seething around us, always changing, always on its way to somewhere else, sometimes with great fury. In the skies and the seas below them, an ancient and powerful engine generates Earth's weather. Fueled by the fires of the sun, it is a machine that converts heat into motion, relentlessly churning the atmosphere into a chaos of wind, rain, and storms. In the 1.5 trillion days since the Earth was born, not a minute has passed in which a storm did not rage somewhere on the planet. But once or twice in a decade, a shift occurs, and hidden energies surge through the system. A mysterious phenomenon called El Nino raises the weather machine to a fevered pitch, causing devastating floods along the coasts of North and South America. Then, El Nino's influence reaches beyond the Pacific coasts, turning lush fields into drought-ridden wastelands, chilling winter rains into lethal ice, transforming dense forests into raging infernos. Only the seasons have a greater influence on global climate than El Nino. Despite its enormous impact, in many ways it remains a mystery. What causes it? What determines how strong it will be? A handful of scientists have embarked on a quest to uncover its secrets. Mike McFadden, an oceanographer, has spent 20 years chasing El Nino.
El Nino is a fascinating scientific problem, and it's challenging in the sense that it requires a variety of skills and expertise to address the issue in a serious and significant way. And so, because of those challenges, it's not routine science. And furthermore, it's science in service to mankind, you might say, that the impacts of El Nino are felt worldwide, and so It's more than just an academic exercise to try and understand it, but it has real value to people all over the planet.
McFadden's team patrols the Pacific Ocean, trying to learn how forces within these deceptively tranquil waters alter weather around the world. The Pacific, the single largest feature on the face of the Earth, controls most of the planet's climate during normal periods and El Niños.
To understand what El Niño is, you have to understand what normal is. And normal is the trade winds blow from east to west, and they pile up warm surface water that's been heated by the sun in the tropics in the western Pacific. And this creates a very deep, warm pool of water. And the system is actually quite stable in a normal condition.
But every 3 to 7 years, something makes the trade winds slacken or even reverse direction. Then the warm water that the winds normally push towards Australia and Indonesia sloshes back across the Pacific toward the South American coast. The enormous pool of unusually warm water changes wind patterns, disrupting normal weather everywhere. Wet places become dry. Dry places become wet. El Niño symptoms are evident, but not its causes.
I think one of the outstanding questions, or mystery if you will, about El Niño is what triggers it. We don't have a theory yet that can explain the onset of all the events that we've been able to observe.
In order to understand El Niño and to be able to predict more precisely when it will occur, Mike McFadden and a group of scientists from the National Oceanic and Atmospheric Administration needed more information from the Pacific. Their work began in 1984 at NOAA's Pacific Marine Environmental Laboratory in Seattle. Their plan was to track El Niño by building a network of electronic sensors attached to buoys.
These buoys measure all the critical environmental parameters you need to know for understanding El Niño. They measure the surface winds, the surface temperatures, the upper ocean temperatures, and at some locations they measure ocean currents.
It took 10 years to move 70 buoys from concept to lab to ocean. But by 1994, the first El Niño early warning system was in place. Stretching across 8,000 miles of the Pacific Basin, it was one of the largest scientific instruments ever built.
I would describe our buoy system as not necessarily high-tech. I would describe it more as ingenious. We make use of technology where it suits our purposes. We do use state-of-the-art electronics, state-of-the-art environmental sensors, state-of-the-art satellite communications. But we've designed the system to be very low power, so we can run them on flashlight batteries.
The buoy array is maintained by a NOAA ship called the Kaimi Moana, Hawaiian for the Ocean Seeker. The crew of scientists and sailors spends 260 days a year tending the system.
Each buoy has a satellite transmitter, so we know where it is at any given time. In the particular case of a buoy at 2 South, 95 West, we saw it move 20 miles from its deployment location over a period of several days, and then it suddenly stopped transmitting. So on our regularly scheduled cruise down this line of buoys, we diverted to the location of the last satellite transmission and then began to scout the area for what we hoped to be the finding of this errant buoy.
We were looking at the schedule.
Mike McFadden joins Captain Mark Kane and Chief Scientist Mark Oblandi in the search to find the lost buoy that cost $50,000 to build, but is priceless in terms of the data it gathers. The buoy is missing from the eastern edge of the array, where El Niño's warmest waters approach the South American coast. Its absence leaves a critical void.
This one hasn't been transmitting since December 13th, so it may not be there, Will.
Yeah, we'll go over there and look, and we can put the transponder hydrophone down and try we should at least be able to find that. All right, let's do it. Okay. Yeah, that's right. We got a big, pretty good sized squall up ahead of us here.
Right.
Probably will not get a visual on it until we're right on top of it.
The watch circle for this thing can be a couple of miles too, so that's going to make it problematic. You'll know it when you see it. It's going to be the only unnatural thing on the horizon.
The rain makes the search more difficult, and they're not sure what they'll find. The anchor line may have been cut, or the buoy may still be in position and not transmitting. But if strong currents have dragged the anchor into deeper water, the buoy may simply have been pulled below the surface.
Nothing yet. Right now we're in a, the buoy's in a, if it's there, it's in a squall. We can't see anything.
They search the vast waters of the eastern Pacific for hours. Their only clue, the location of the last satellite transmission before the buoy stopped sending data. When they reach that position, they send a signal to a device called an acoustic release attached to the anchor of the buoy. But the signal can only be received if they come within 5 miles of the missing anchor. For several hours, there is no response. Perhaps the buoy has drifted. Finally, they have some luck.
Yeah, we got it.
The ship's repeated queries are received by the acoustic release, which beams a reply signal back to the ship. The crew homes in on the location of the anchor and then sends another signal, ordering the acoustic release to uncouple the mooring line. If the buoy is submerged but still attached to the line, it should pop out of the water.
Go ahead, Rick. Yeah, let's fire it, Rick.
I'll have the deck department prepared for a deploy.
Okay, we're about done.
We triggered the release hoping that it would pop up on the horizon and there would be a great hurrah that we had found it.
Nothing, huh, guys?
0.
Despite their best efforts, the buoy is gone. The loss of a buoy is a cost of doing business in the Pacific, where powerful ocean currents can sometimes dislodge even 4,000 pounds of anchor. But in this case, the ocean might not have been the culprit. Buoys attract fish, so fishermen have been known to borrow these rather high-priced lures.
In not all cases do fishermen understand how fragile the instrumentation is or how important the data are actually for their own activities. And in fact, on some of the buoys we serviced on this particular cruise, we found fishing gear and other evidence that these buoys had been visited by fishermen.
Peruvian fishermen have always been the first to know when an El Niño was underway, and the first to suffer its consequences.
The El Niño current makes the water hot and the fish don't like that. They move out where the ocean is cooler, which is too far for us to follow in our boats.
In most years, Peru is the #1 fish exporter in the world, mainly of anchovies and sardines processed into fish meal. But during a major El Niño in the early 1980s, the industry collapsed. The 1982-83 El Niño wreaked havoc throughout Peru, where areas in the north received 30 times the normal rainfall. With no advance warning and no emergency preparations, Peruvians suffered $1 billion in damages. Reaching well beyond Peru's borders, El Niño's worldwide toll would rise to $13 billion in property and crop losses. $2,000 people would die. For the first time, El Niño would be recognized as a force of global influence.
As a scientist who's based his career on the study of El Niño, you sometimes lose touch with the human dimension. And to see the flooding and the inundation was a very moving experience, because it reminds you and humbles you that this phenomenon affects the lives of so many people. And makes you understand and appreciate the importance of what it is you do, and the hope that that information that you generate can be used in ways that can mitigate against some of this human suffering.
Before the devastation began in 1982, the El Niño had grown steadily for months. But with no buoy array at the time, the scientific community was caught off guard. Climate scientist Tim Barnett of Scripps Institution of Oceanography was one of dozens of experts in the early 1980s who was watching for El Niño.
In September of '82, there was a conference on El Niño, and everybody was there. And I think it was the consensus of that conference, or at least most of the people, there would be no El Niño that year. And of course, we were 2 months away from the height of what at that time was the biggest El Niño of the century.
Unfortunately for the climatologists, they'd been misled by a volcano. In Mexico, El Chichinal had recently and violently erupted. Highly reflective mist from the volcano had obscured the vision of satellites circling above, falsely lowering readings of sea surface temperatures by several degrees, masking the growing El Niño. On the eve of the next major El Niño, forecasters would have a new weapon in their diagnostic arsenal. They'd have the buoy array. The buoys would provide the first accurate portrait of the entire Pacific Basin, precise enough to calibrate satellites that were once deceived by a volcano.
I think the strength of the El Niño observing system is that we have both a combination of satellite measurements and in the ocean measurements. The satellites give you a global picture. Unfortunately, they see only the surface. If you want to understand what's going on below the surface, you have to put instrumentation into the ocean.
Deploying a buoy is perhaps the most challenging operation on board the Kaini Moana.
How's our speed moving, Jeff?
If all goes right, it should take about 4 hours.
We start by rigging the buoy, putting the instrumentation on, putting the lines on. Antenna. After that's done, it's hoisted over the side with a crane. All the crew is out and they've got their ropes on it, and you see men and machines working against or with the sea as it may be.
Up a little bit. That's good. Moving up, around. About halfway to the water. Good.
Once the buoy is in the water, the crew reels out nearly 3 miles of mooring line, which carries sensors to measure water temperatures and currents at various depths. Without the buoys, these scientists would be as blind to a growing El Niño as they were in 1982. With them, McFadden and his team know, as it's happening, when an El Niño is brewing.
Whoa, that is warm. 29.8. That's why we can't run the engines at full speed. Can't cool them in water this warm.
Water temperature of nearly 86 degrees Fahrenheit, roughly 15 degrees above normal in this part of the Pacific, is a definite symptom of El Niño. One of several indicators the buoy array measures to detect an impending event. In December of 1996, the first hints of a change began blowing in the Pacific. Suspicious wind pulses started, fluctuations that can sometimes mark the onset of an El Niño, but not always. Then, over the next few months, the buoys detected signs of something more ominous. The trade wind slackened and ultimately changed direction, almost certainly heralding a new El Niño. This time, people were watching.
The information from this buoy array is used widely all over the world. Centers for weather forecasting and climate forecasting make use of this data. It's ingested into their computer models.
For our model, we know the basic physics that govern the ocean, changes in temperature and currents and so on. And we can write those down as a set of mathematical equations. Now, once you have this large set of mathematical equations, they're too complex to sit down and just write the answer out on a piece of paper. So that's when you turn to the computer and program the computer to solve those for you. And the net result of that's called a model. And the net result of that then is an El Niño forecast.
Processing information collected by buoys and satellites, Tim and other climate modelers were able to do what they couldn't just 15 years earlier. See an El Niño coming. Within weeks of their forecast, warm water began racing toward South America at a rate of up to 150 miles a day. Sea surface temperatures in parts of the eastern Pacific rose 5, 10, over 15 degrees Fahrenheit. The heated water contained a staggering amount of energy, equivalent to exploding 500,000 20-megaton hydrogen bombs. This is the energy that would fuel the disruption of the world's weather. While most major computer models did predict the 1997-98 event, they forecast an El Niño only of minor to moderate intensity.
None of the forecast models predicted how huge it would be, and none of them predicted how rapidly it was going to develop. And so there was a surprise here Different than the surprise in 1982-83, where we didn't even see it coming at all.
There were several of us that forecast this event a year in advance. Well, at those long-range forecasts, we missed the magnitude by almost a factor of 3. Almost a factor of 3. We would have said, yes, in January of last year, there's going to be a mild or moderate El Nino. Well, it was a whopper.
We've studied El Nino long enough now to realize that when it occurs, there are identifiable impacts all over the world. The heavy rains and flooding in North and South America, droughts in South Africa, droughts over the Indian subcontinent. We can interpret disparate events happening around the world that you would normally think are completely unrelated. So why should these be related? Because they all have a common origin, the tropical Pacific.
The normal equilibrium of the ocean is upset by the abnormally warm waters of El Nino.
At high temperatures, you have much greater evaporation of moisture, and this moisture-laden air, when it rises, condenses and precipitates out in the form of rainfall. During El Nino years, the heavy precipitation that is normally found over the western part of the Pacific, Australia, Indonesia, and the Philippines, migrates eastward with the warm water. And so what that does almost immediately is it leaves Australia, Indonesia, and that part of the world high and dry, drought, potentially famine, and all the ramifications that go with that.
In Indonesia, farmers light fires every year to clear forests for planting. Normally, they can rely upon the rains of monsoon season to douse the flames. But during the El Nino-induced drought, fires raged out of control, filling the air with choking smoke, pushing pollution levels to record highs, and sending tens of thousands of people to seek medical aid for respiratory ailments. All because the rain moved eastward.
When you change this precipitation pattern, you're also changing the heating for the general circulation of the atmosphere. And so this has impacts not just in the Pacific Basin, but all around the world.
The entire tropical circulation around the entire planet is linked together. And so when you have an El Nino, let's say in the Pacific, it affects that entire circulation, which affects the winds and the rains and so on over the Indian Ocean and somewhat over the Atlantic. I think we were all sort of stunned to see that this patch of water in the Pacific Ocean could have impacts on such far-reaching areas of the globe, as has now been shown quite clearly.
When El Nino's pool of exceptionally warm water evaporates off the ocean's surface, it doesn't just form clouds. It also creates a huge column of warm, moist air that bulges upward 6 to 10 miles into the sky. Like a boulder in a river, this mass of air forces winds to flow around it, displacing the jet streams and the weather patterns they deliver to the rest of the world.
The El Nino is not a storm. There are not El Nino storms. There are storms all the time, whether there's an El Nino or not. I think people think of it like that. But what it really is a fairly momentary change in the climate of planet Earth. That's what it is. And so as that climate changes, all the details of the climate, the weather, change too, which is what we see.
The climate changes reach all the way to Africa, where some countries flood, while others endure droughts. The same area can be wet in one event and dry in the next, depending on the fickle twists and turns of air currents disturbed by El Nino. dislocated jet streams deliver fierce storms to California that would ordinarily land far to the north in Alaska or Canada. California's magnificent coastlines normally erode 4 inches a year. But during the first few months of the 1998 El Niño, some cliffs retreated 10 feet. Despite early warnings, scores of homes could not be saved.
The winter storms this year have been really remarkable, and I think a number of us scratching our head, because you can look at a satellite picture and you see them lined up, particularly in February, 3 or 4 of them all coming zip right across the ocean. And the path they took was just, bam, bam, right into Central California time after time.
Meteorologists working in California had to improve their ability to forecast which El Niño-powered storms would strike the coastline and which ones would wait to hit the more desolate inland mountains. There was an urgent need to know how this global climate event would affect local conditions. A research team led by Marty Ralph planned a daring series of flights that would measure storms by flying directly through them, gathering information that is otherwise impossible to get.
The basic problem is this region out in the Pacific has very limited data. There might be 40 measurements from a handful of ships going through, maybe some commercial aircraft that are flying up at high levels. Over a comparable size area in the US, there are probably 20,000 measurements. So we call this the Pacific data void. And one of our objectives is to get detailed measurements out here.
With weather radars and wing-mounted sensors, Marty and his team measure wind speed, temperature, rainfall distribution, and atmospheric pressure from within the storm as it heads directly for California's Monterey coast. In order to create a 3-dimensional portrait of the storm, readings must be taken at a range of altitudes, beginning at just 200 feet above the ocean. As the plane crosses the storm front, passing from relatively stable cold air to El Niño-energized warm air, the ride gets rougher.
Our position here is about 50 kilometers ahead of the front. The winds right now at our location are at 50 knots.
We could end up with hurricane force winds up here along the coast.
Yeah. El Niño pumped this storm full of tropical heat and moisture, 2 primary ingredients for enormous precipitation. But Marty's team still couldn't be sure where this storm would hit, inland or at the coast. Then, a few miles offshore, they observed something unexpected. They found a wall of air called a blocking front that was forcing the precipitation out of the clouds near the coastline.
We saw something that makes the rain form offshore first before it hits the coast, and that was a blocking front. This may be useful to help forecasters better predict whether to expect the heavy rains right at the coast, where the highways are, where the people live, or inland in the mountains where they usually get them. It's moistening up in that barrier flow. Yep. So where that thing goes up the slope sometime later today, further north, that's going to help create a lot more rain.
I was surprised. I thought this area out here was going to be the moist one, but no, the area in there was the moist one.
We just discovered something.
Yeah.
All right. Nobody can argue with what we found today. So I feel like in my career, there's been a handful of times when I sit back and say, you know, I found something new today, really new. And this is one of those days.
The discovery of blocking fronts helps explain why parts of California's coastline endured some of El Niño's fury. Still, other places in the United States actually benefited from the climate change.
There are winners and losers with El Niño. It's clear that people suffer when there are heavy rains and flooding or droughts and wildfires. But it's not a complete negative phenomenon from that point of view, because it tends to reduce the number of Atlantic hurricanes, for example, and that has a very positive benefit to people who live on the east coast of the United States.
The 1997 hurricane season was one of the quietest on record, with only 3 hurricanes, half the number that typically strike. Winds high over the Atlantic, stimulated by El Niño, blew developing hurricanes apart before they had a chance to organize and grow. In the Midwest and northern United States, places that normally bear the brutality of winter weather found relief in El Niño.
The winters in the Pacific Northwest in the northern tier of the United States tend to be warmer, and that reduces heating costs. It's a two-sided coin. On average, I would say it's more negative than positive, though, for human activities.
El Niño always strikes Peru first and hardest.
There's no place for me to go. With the first rains, my house was destroyed and I moved away. Now, these rains have destroyed my house again.
The 1997-98 El Niño left 250,000 people homeless. Nearly 300 dead. And an unknown number of casualties from malaria and cholera, diseases that inescapably arise from stagnant floodwaters. But the advance warning of El Niño did help some Peruvians prepare for the onslaught. Based on an estimate that every dollar spent on prevention would save $10 in disaster relief, the government began widening some waterways in northern Peru that were sure to overflow.
In 1983, it was 6 months or 8 months, not only of water, but of mud. Now, the flood may stay 6 hours, 10 hours, but after that, the city again is clean. That's a big difference.
Still, the advanced warning could not bring fish back to Peruvian waters. Independent pescadores, still using reed boats their ancestors have made for generations, cannot earn a living during El Niño.
In most years, I can catch 80 kilos. This year, I have only gotten 20 kilos. This year is much worse than 1982. This is the worst El Niño I have ever seen.
Fishermen with no catch participate in ancient rituals meant to bring fish back to their empty nets. Peruvian shamans have been helping their faithful contend with El Niño for centuries. But no one knows just how long and how often El Niño has been influencing the Earth's weather. Archaeologists working at one of the largest pre-Columbian temples in South America are uncovering new evidence of El Niño's destruction, dating back to the 6th century. Near Trujillo, in northern Peru, sits the ancient moche Huaca de la Luna, the Pyramid of the Moon.
Arqueológically, here at the Huaca de la Luna, we have found 3 events of the El Niño phenomenon that come between 550 and 650 AD. The collapse of the Moche culture probably happened in a very large period between 600 and 800 AD, after the El Niño storms.
The Moche predated the Inca, and their capital, while quite sophisticated, was built of mud bricks, highly vulnerable to any flooding.
There were canals that supplied water throughout the city. When the El Niño happened, these canals flooded and inundated the city and destroyed the basis of the foundations of the buildings. The houses began to collapse.
As this flood overran the Moche city, torrential waters deposited smooth stones that could only be found in the riverbed nearly 2 miles away. Testimony to the force of the deluge that overwhelmed these people. More digging behind the Pyramid of the Moon led to another disturbing discovery. 90 skeletons buried under 15 layers of mud.
They had all been sacrificed in 3 distinct ways. 1, with a blow to the head, 2, slashing the throat, and 3, with spears.
In their desperation to stop the floodwaters of 560 AD, the Moche sacrificed men, women, and children to their gods.
We have evidence that these sacrifices were generated when the El Niño rains poured down. The first is that these enclosures were closed, and the mud could only be caused by very strong rains that melted the adobe walls. And secondly, the bodies are imprisoned in mud, which means the mud was still fresh when they made the first sacrifices. The sacrifice of 90 people represents a symbolic act of the Moches to atone themselves with their gods.
It is a chilling reminder of El Niño's power over the course of civilization. But each El Niño also leaves an imprint on nature. Tree rings record the age of a tree, but the familiar bands also bear the marks of past El Niños.
I'm a dendrochronologist, which means I study the growth of trees as an indicator of past climate and past events. Trees have a story to tell us, and my job is to interpret what they are telling us. To obtain a sample from a tree, we extract this core, which is only about 5 millimeters in diameter, so that we don't cause any damage to the tree. The chronology will have years that show little growth and years that show higher growth. The larger growth years are the years when there was higher winter and spring precipitation. That is the El Niño signal that we see in the tree rings.
Franco Biondi generally samples trees in regions where it normally does not rain. So when he sees large annual growth bands, he knows they must be the result of precipitation from El Niño. To identify specific years, he must cross-match samples in the laboratory.
The visual matching of the ears is done underneath a microscope. We can see the history of El Niños from tree rings as far back as the age of the trees.
In the rings of the oldest trees he has sampled, Franco has been able to detect evidence of El Niños dating back more than 300 years.
All right, first, the rings are going to show up pretty well.
Other tree studies reflect an increase in the number of El Niño events beginning in 1870. But dendrochronologists will have to compare their results with other historical records before they can be sure that the frequency of El Niño is really on the rise. The dramatic history of El Niño's impact on nature can best be seen on the Galapagos Islands. Lying on the equator, 600 miles off the coast of South America, these remote islands are steeped in some of El Niño's warmest waters. Here, the ocean determines who wins and who loses during an El Niño. But no animal is left untouched. In the overheated seas of the 1982-83 El Niño, fish-loving Galapagos penguins starved, losing nearly 80% of their population. But tortoises and finches, land-based creatures, flourished on the suddenly verdant islands.
The mystery of the Galapagos is how the species on these islands have adapted over the millennia to the occurrence of El Niño, and how that's changed the course of evolution. We haven't thought of it in these terms before, but El Niño is a very strong force in evolution of the species, at least in this region.
Perhaps the strongest evidence of El Niño's evolutionary influence was seen in 1982, when El Niño returned to the Galapagos. It poured rain for 8 months over these island deserts, triggering an extraordinary response in some of the animals. The medium ground finch, one of the 14 species of birds known as Darwin's finches, always exists with a range of beak sizes. But in the drought that preceded El Niño, large beaks dominated. Then, within just a few months of the onset of the El Niño rains, conditions began to strongly favor birds with smaller beaks. The little beaks were far better suited to feed on the small, softer grass seeds prevalent in the moist climate than the bigger, harder cactus seeds that normally dominate these islands. During the El Niño, the finches began reproducing at a feverish pace. Some birds bred not once, as might be expected, but 8 times. Even juveniles as young as 3 months old started breeding. The change in the climate had turned the finches into mating machines. By the time the rain stopped, the population of all finches had skyrocketed. But continuing abundance of small seeds greatly favored birds with small beaks. On one island, the population of medium ground finches, once dominated by big beaks, had shifted dramatically. This group was now mostly smaller beaked. These finches were changing their form in response to El Niño. Evolution is normally thought to operate on time scales of thousands of years. But here was clear evidence of natural selection producing striking changes in mere months. The remarkable ability of a species to respond to the climate takes a long time to incorporate into a population of animals. And it suggests that El Niño has been visiting these islands for a very long time.
I think it's fair to say that as long as there has been a Pacific basin whose boundaries are approximately those of today, that El Niños have been occurring. Now, the present boundaries of the Pacific basin were established about 3 to 5 million years ago with the closure of the Isthmus of Panama, that strip of land that connects North and South America. And so one could surmise that El Niños have been occurring for at least 3 to 5 million years, and possibly longer.
If El Niño has been a natural part of the Earth's climate cycle for so long, predating human presence, it's clear that people haven't caused the phenomenon. But have we changed it? Until very recently, an El Niño of the magnitude of the one in 1982 was thought to occur only once in a century. But then, an even greater event struck a mere 15 years later, provoking the question, is there a connection between El Niño and the gradual warming of the Earth's atmosphere?
There's the whole global warming issue. I mean, we're doing something to the planet, there's no doubt about that. What the consequences will be, we don't have any idea.
It's plausible that change in character of El Niño events may be related to global warming. But there are also other possibilities that can explain the intensity of this event or some of the unusual characteristics of El Niños in the past 10 to 15 years. The jury is still out as to what the impacts of global warming are.
Beyond global warming, many questions remain. Will anyone ever be able to precisely predict when the next El Niño cycle will begin? Where it will hit? And how hard it will strike? Will Mike McFadden and his colleagues at sea discover what triggers an El Niño and how the seeds of its destruction are sown? Will the Pacific ever reveal its long-held secrets?
When I'm looking at the ocean out on the ship, I'm really not looking for anything in particular. It's more a contemplation. It's kind of immersion in the environment of the sky and the sea and the waves and the wind, and understanding that scientific progress is based not only on the analysis of hard numbers, but sort of the intuition you gain from being there and understanding the things that you really can't quantify or measure directly.
The only certainty in this ocean-born mystery is that these scientists will soon have another opportunity to test their theories, because inevitably, El Niño will return.
When it does return, will you be ready? Log on to the ultimate El Niño guide on NOVA's website at www.pbs.org. To order the show for $19.95 plus shipping and handling, call 1-800-255-9424. And to learn more about how science can solve the mysteries of our world, ask about our many other NOVA videos. is a production of WGBH Boston. Major funding for NOVA is provided by the Park Foundation, dedicated to education and quality television.
And by iOmega, makers of the zip drive and 100 megabyte zip disks, proudly bringing you the opportunity to learn new things and the space to store them in your own personal library. iOmega, because it's your stuff.
This program is funded in part by Northwestern Mutual Life, which has been protecting families and businesses for generations. Have you heard from the Quiet Company? Northwestern Mutual Life.
And by the Corporation for Public Broadcasting and viewers like you.
This is PBS.
Next time on Nova, 2 killer quakes, exactly 1 year apart. In Japan, deaths in the thousands. In California, damage in the billions. Most frightening of all, the quakes happened at unlikely places. And chances are, they'll happen again. Are these seismic hotspots doomed? The day the Earth shook. That's next time on Nova.